Hi, everyone. Okay, so let's begin. So first off, thank you guys all for joining us on this webinar. We have a lot of content to cover today, so I'm going to keep this short. For those of you unfamiliar with ENFOS, we provide a cloud software solution used by companies all around the world to organize their environmental liabilities. So ENFOS is a platform that connects all of the complex information involved in environmental remediation and decommissioning. So today we have Roger Well, VP and COO of ENFOS, who's going to be taking us through 5 essential information management trends that we're seeing in the remediation field today. Before I give it to Roger, just to let you know, you should be able to submit questions throughout the webinar via the questions tab on your dashboard. So we're going to try and save some time for questions at the end, but we do have quite a bit to cover. So any unanswered questions are going to be followed up via email. And with that, I'll pass it on to Roger.
All right, thanks, Chris. And we were testing the audio right before the call, and I was told that I'm a little bit choppy on my voice here. So I will attempt to speak a little bit slower and directly into the speakerphone. As Chris said, thank you for taking time out of your schedules to attend our webinar. We have webinars both for the industry in general and then also webinars that are specific to ENFOS and the ENFOS functionality. This is one of our general webinars, and we had excellent interest in this, lots and lots of registration. So we're very happy to hit on a topic that is of concern to everyone that's attending. So today we're going to start out with an overview and talk about information technology as it relates to the remediation industry. Then we're going to go into 5 of the trends that we're highlighting today, and then we'll end up with a question and answer. So let's start off with setting some context. And when we talk about technology at ENFOS, we're specifically addressing information technology. We know that many of you on the call not only use information technology, but also remedial technology. And I just want to point out that the context of our reference here is around information and not remedial technology. So let's start off with a kind of a context setting slide. The 21st century enterprise in today's digital world is really keying in on 4 broad areas. Software as a service. You also hear that referenced as SaaS. This is usually led by commercial software companies like ENFOS that have developed products that are specific for an industry or a business function. We also know that the nature and value of our digital assets is changing. Decision support, connected devices, and so on. Another major element is around the workforce of the future. The people that are coming into our business or have been in it early on in their careers, they're expecting workflow automation and they're demanding high tech. We also have a lot of people working remotely these days, and collaboration is a very important piece of that. And then finally, people engagement. That's the personalization, the self-service nature of knowledge management, and so on. The enablers of these areas are listed on the left-hand side. The items that are in italics are the areas that we're going to touch on today, such as enterprise technology, cloud, business process automation, business intelligence and analytics, data visualization, and artificial intelligence and machine learning. There are other enablers that are listed here. We won't be touching on those. Those are just as important, but we only have an hour, so we're trying to key in on a few of these. In context of the remediation business function, we have a diagram that we generally lead off almost all of our webinars on, and it really lays out the industry as we see it. We have these outside influencers such as environmental regulations, financial disclosure regulations. We obviously have property owners and people living around the properties in the communities. Many business functions take some role in contaminated site management. We're generally dealing with many sites, not just one. So facilities that are located, within the global world here, and we've got different currencies, different languages, different units of measurements, and so on. But we are dealing with portfolios of sites. The work that we're doing together is considered a complex service. These are projects that have long life cycles. Throughout those long life cycles, there are thousands of transactions and documents and communications. We know it's a complex regulatory environment. The work is outsourced to environmental consultants, contractors, laboratories, and so on. There's a complex accounting nature to what we do because we're dealing with a balance sheet item, which is the environmental liability or the asset retirement obligation. And the state of the industry that we see really is in a place where they're using disparate systems. So let's talk about that a little bit. Why do we think that's the case? So when we're talking to customers, prospects, consultants who are working in the field, these are some of the things that we will hear. And we thought that this would be a slide to kind of identify the problem statement, if you will. In other words, why is our industry lagging somewhat compared to other business functions in this area of adopting high tech? Probably first and foremost is that the remediation business function is a cost center and not a profit center. The industry, as we know it, developed its core capabilities before the dot-com bubble of the mid-90s. So that included how data is captured, processed, and acted upon. Remediation is a mature industry, at least in North America and Europe, and it's performed by mature organizations. That's generally not a good recipe for innovation. We hear that we've had past failed technology initiatives and promises that either didn't pan out or they didn't scale up when when the industry tried to scale those to an enterprise level. Obviously, reluctance to change, risk versus reward perceptions. This gets into the return on investment and the promise. Remediation gets dragged into using generic business applications not fit for purpose. So we see a lot of general business applications that are being cobbled together for the remediation function to try to help companies do their work digitally. And then finally, there is some lack of experience with leadership within our industry around tech-driven business transformation. A lot of these are changing, and some of those factors or obstacles are changing very quickly. We want to hold out a little promise here, though, and talk about some of these points. So those that are slow to adopt new technology often benefit the most. So there's some hope. So if your organization is maybe lagging behind in some technology adoption, you can hold out some promise that other organizations maybe were early stage adapters and went through some growing pains, and maybe your organization will experience fewer of those. The ongoing technology waves, and that is plural, are only growing stronger. We're going to talk about some of those. So this is a never-ending digitization process taking place in the age that we're in. The younger workforce demands it, right? These students coming out of colleges and universities today were obviously involved in tech early on in their lives, so they expect and demand it. And there is a strong business case in ROI. we typically see a ROI of 500% or greater for organizations that are considering an enterprise application for their remediation function. So let's get into the 5 areas that we want to highlight today. So the first area is knowledge management. Most of us think of knowledge management from the value stream, where you go from data to information to knowledge, and that still holds true. A lot of experts in the knowledge management area will frame knowledge management into 3 broad areas as shown here in the Venn diagram. There's a technology area, a process area, and a people area. All 3 are as critical as the next. For our talk today, we're going to focus on technology and process primarily. So the first item that we want to bring up in the knowledge management area has to do with the type of data that we're dealing with. So in general, all industries are dealing with both structured data and unstructured data. Structured data, you might want to think of, this would be data and content that would be contained within a relational database. It's easily searchable. Right? There's some kind of organization and structure to it, and a data quality management component to it as well. Unstructured data is just the opposite, right? We typically think of unstructured data as files, documents, right? They could be in different types of file formats, PDFs, Word, Excel. They can be notes. It can be content that we find through internet searches or research that we're doing online. So that's the unstructured data, and that's making up greater than 80% of the universe of data that's out there. We're going to talk more about this in the last section when we get into machine learning as well. But when you talk about knowledge management, you first have to think about it in these 2 broad categories. The next item has to do with the curation of data. For remediation, you'd want to think about your data in categories. So some kind of a classification and categorization. For structured data, this is a lot easier in terms of your data capture, data preparation, and so on. As an example, in the ENFOS system, we have different modules that contain structured data in these types of categories. For unstructured data, it's more difficult, right? The basic area of organization might be a folder directory structure for files and documents. But the rest of the information in unstructured data is going to be buried in the content of those documents. So for remediation, the risks that categories are identified here were actually developed by the ITRC in their 2011 study around remediation project risk management. It's an example of how your knowledge might be curated, right? There's that strong organizational component. The next item in knowledge management we want to talk about is taxonomy. So this is really the arrangement of your knowledge. It's definitely tied to master data management. And you can generally think of it as a hierarchical structure of our non-transactional data entities. So for ENFOS customers, you'll recognize this diagram as an example of the ENFOS hierarchy. And it's designed to reflect the customer's portfolio of environmental projects, from the owner level all the way down to the lowest level in the hierarchy, which is generally a project or an area of concern, as shown here. So this taxonomy is a very critical element in terms of how we're capturing, organizing, and accessing information. We like to think of the hierarchy as a tree. And on that tree, you have these nodes. We have our sites, we have our areas of concern, and we're going to hang information. We're going to associate content to those nodes so that it's easily accessible, easily to locate, and easily to search and query for converting our data to knowledge. So to end up in this area of knowledge management, these are some of the critical features that are trending. Obviously, enterprise content management and enterprise document management. A consolidation of your indexed content, right, through OCR and indexing algorithms. With that, you'll have your standard keyword searches for tags, titles, metadata, and so on. There should be a human association. We call those contacts and roles, but in general, this would be used to locate experts based on the type of problem or the type of remediation issue we're dealing with. So there has to be a human association to the knowledge base. Data repurposing across multiple functions. Classic example is an invoice from a contractor on a remediation project contains a lot of information that should be repurposed for project management and project tracking purposes. So that's an example. Drill downs for multidimensional exploration, and then certainly subject matter expert systems like ENFOS that are designed and built specifically for the business function that we're talking about, in this case, remediation. Okay, we're going to move on to the second area, a convergence of technologies. Have a definition here. I think that the short version of the definition is to think about convergence of technologies is you're leveraging different technologies in a single application. Okay, we see this a lot in our day-to-day applications that we use, whether we've got voice recognition on top of our map and GPS system. You know, you can think of many, many examples where technology companies are basically bringing multiple technologies into a single platform. That is a very active trend in the industry and will continue to be. So what's the opposite of convergence? Well, that's when you have data silos within your organization and also within your supply chain. In remediation, we've listed about 15 or 16 of them here. And we've seen cases where all of these, and maybe more, all these data categories exist in different systems. And this is multidimensional. It's not just a single dimension here, because you've got many, many suppliers, many, many laboratories, many contractors. You've got thousands of spreadsheets that are supporting these data silos. So it's a big problem, especially as you talk about how are we preparing ourselves for the future to actually leverage our data. So these are classic examples of where we see data silos. Content management, notes, our accounting for our liabilities, our environmental data management, our project management, and so on. So what subject matter expert software does is it combines those various technologies into a single application. And for remediation, we always talk about it as being a complex service that has complex risks and a complex accounting nature to it. That's the accounting for the environmental liability and the asset retirement obligation. Another convergence of technologies has to do with business intelligence and analytics. There are many standalone analytics and BI packages out there. What state-of-the-art software companies are doing that serve a specific business function like ENFOS does is they're embedding the BI in the analytics tool directly into the primary application, right? So there's a lot of underlying user security and access control and other infrastructure that goes into this. but it also allows a product like ENFOS or any subject matter expert system to be able to design the BI tool to fit the needs of that industry. So this is an example of the new Insights submodule that's going into ENFOS. It's under beta right now. We had an entire conference last year just on business intelligence. And as you can see, it gives all the core functionality necessary to analyze data, including all the data preparation in advance, the data tables, the dragging and dropping to create columns and rows and measures, crosstabs, and then certainly a graphics package on top of that to produce not only tabular reports, but also dashboards. Again, ENFOS is in beta right now, and we expect to have our BI tool out to additional users within the next few months. So the next category is ownership versus possession. What we're talking about here is data ownership versus data possession. So this model really shows the three general approaches that organizations take when it comes to their data architecture. On the left-hand side, we have a fully decentralized data governance model. And on the far right side, we have an enterprise model. And in between is a hybrid. In our industry, we have a lot of stakeholders, right? We have administrators. We have responsible parties. Those are the owners' employees. We have laboratory users, consultants, contractors. There are internal customers. And there are other specialists as well. The majority of the industry is probably somewhere between decentralized and hybrid, with a few leading edge companies on the enterprise side. The hybrid is a model by which each stakeholder is responsible for their own content, of course being paid for by the owner. And they're moving their content in a final form, a final deliverable to the customer that then maybe stores and retains some of it, maybe not all of it. The enterprise model is a completely different model by which there's a centralized enterprise application that all stakeholders are managing projects, managing the data, managing the reporting and outputs within the main platform or the enterprise system. So considerations for this. So data ownership and data stewardship falls under data governance. Most organizations have some type of a data governance strategy from which policy and procedure will follow on. Enterprise technologies are game changers in this space when it comes to data governance as well as this ownership versus possession issue. That's because enterprise technologies can create uniformity in the data design and structures, can establish your end-to-end standards from the data capture all the way through your final storage, can enforce your data quality and completeness requirements, or also error proofing. Enterprise technologies, maybe the number one sub-bullet here, is that data and content, particularly the structured data, is analytics ready. So with the decentralized and hybrid models, data analysts will spend up to 80% of their time preparing data and only 20% actually analyzing it. So that is upside down. That needs to be flipped, and it can be. You want your data scientists, your analysts, your project managers, and so on actually analyzing the data or using that data for decision making. Other considerations that we want to bring up are data access, privacy, security, and business continuity. Those are very critical in this area of data possession. Also, and finally, data possession reduces the impact of employee turnover and supplier switching. So you have to keep in the back of your mind, particularly if you're a leader in one of these organizations, the aging workforce, retirees, people that are transferring out, and so on. So the possession of what you own, we believe, is a critical element and certainly a trending area in high tech. Okay, this next area is the hybridization of business process management. It is different than convergence of technologies. So on convergence of technologies, we're bringing multiple technologies to bear into a single application. On hybridization, we're taking business processes and connecting them. So the smart technology is finding those connections between separate processes, joining them, and then delivering a unified super process that gives real-time feedback to the end users. We have 3 examples of this that we want to share. The first one is around environmental reserve and spend management. There is a super process that combines the planning and budgeting piece with the spending piece. And spending always starts with proposals from contractors and consultants. Those flow to purchases or work commitments. And then when the work is actually being performed, there's an invoicing and or a cost recovery element. So joining those 4 broad process areas into a super process is a best management practice. When you do that, you're getting multiple benefits. The most basic benefits are that you're reducing data administration, you're reducing data entry or redundant data entry, and you're also freeing up time of your staff to focus on the most important things and not on consolidating data, rolling up spreadsheets, managing versions of multiple spreadsheets, trying to take invoice data that's probably on a PDF file somewhere and matching that up into a reserve on a project to calculate a balance or a purchase order. Those are the most basic. Now, the higher advanced benefits get to do with automated reserve accounting and understanding what you're getting for your money and also the progression of your projects through their life cycle. So with this environmental reserve and spend management, this is very industry specific because it has to do with liability accounting. So a system that's a subject matter expert system in our space, our field, needs to be able to handle the reserve balance calculations. It needs to establish financial control points for work commitments and spend controls. So that, as an example, at the bottom here, I'm showing a reserve balance. On that reserve balance, there are open commitments already outstanding. These would be work commitments or purchase orders already approved, less what is still to be invoiced. Then I have an available to commit out of my reserve balance, which serves as the upper limit on any future work commitments on that project or site. So these built-in internal financial controls add a higher level benefit to these super processes. That's example 1. The second example has to do with a very common transactional product area called purchase to pay, or P2P, sometimes called procure to pay. This has a lot to do with sourcing to the supply chain. It has to do with obtaining purchase orders and then the submittal of a service receipt and also the invoice. What technology gives us today with these hybridization of these business processes is that we can take an area like project management and combine that with purchase to pay to come up with a new product that's basically project management enhanced purchase to pay. So these organizations managing remediation, this is all project-based work. And it's also outsourced. So by combining your project management with the transactional activities, you have created value for the organization. So we've listed some of these project management elements as well as some of the P2P elements so that you can see or the illustration of what those are. So for project management, you see things like scope management, schedule management, cost management. You've got deliverables and milestones. If you're using waterfall project management methodology, you have Gantt charts, earned value, and then obviously you'll end with a project closeout. That work has to be done regardless of what system you're using, but so does the purchase to pay because it's outsourced work. So those elements include things like your vendor master and your catalogs. Those are the rate sheets that are associated with your vendor's master service agreements. Your DOAs, your accounting codes or chart of accounts, WBSs, RFPs, proposals, requisitions, receipt of services and invoices. So a super process or hybridization is merging the two for the business function like remediation that does project-based work. It's a necessary front end to the purchase to pay. And then the last example, a little more basic here. In the remediation field, we love our maps. Data visualization has been a key part of our work. And what we're seeing with the hybridization of processes, we're bringing financial data into our data visualizations. And that field is called geo-accounting, and we're just showing an example here. We're visual individuals normally. We have large portfolios of sites or projects, right? Not just in North America, but globally. And we're able to run queries, and we're able to spot trends or heat zones that have particular concern to us or help us find leading indicators of projects that might need some additional support. So that's the third example in hybridization of technologies, of processes. Okay, the last area is the rapid emergence of machine learning. This is an area that is growing exponentially. When you talk about technology and the areas of data science, this is the area. Investment in this area is very high. There's a high promise in this area for almost everything we do as human beings, but certainly it's going to apply to our industry as well. So the basic idea here around machine learning and artificial intelligence, this is an area of data science where computers are being trained, i.e. they can learn from data without explicitly being programmed. And that's done through an analytical modeling engineering process using neural networks. You have an example here where we have inputs and we have outputs based on our needs. And then the hidden layers are where the data scientists and computer scientists are working behind the scenes to develop the algorithms for the machine to be able to take both structured data as well as unstructured data and perform algorithms to produce some type of output. And we're going to talk about some examples there. ENFOS is working right now on some research projects with MIT, and we're focusing on machine learning, but a sub-area called supervised learning. And these are techniques to map some X to Y. It's the basic input to output that we looked at on that neural network. But some other examples here will relate to our industry. Actual spend to forecasted spend. Remaining budget to a potential cost overrun. A reserve balance to a projected reserve replenishment. Documents, right? That's our unstructured data. So documents to key data locked in them. Attributes to risks. So in our area, we're talking about location attributes, hydrogeology, contaminants, risk, and so on. And then finally, conceptual site model to remedy selection. So these are examples of the X to Y that machine learning will be attempting to help our industry out. This doesn't mean that we're going to have machines doing all of our work, but there are many, many use cases that machine learning can certainly help our industry out. And who knows where it's going to be at 10 years from now. But in the short term, you're going to see more and more initiatives come out around this in your organizations. So I mentioned that we're working with a group from MIT, and two of the projects that we wanted to talk about are in our remaining slides. So one of them was a classic problem in many industries, but that classic problem is forecasting, improving the accuracy and precision of forecasting. In our case, we're talking about life cycle forecasting. Those can be used for reserve estimates. They could be used for just planning and budgeting. They could be used for just establishing some other type of a guideline to compare what our project teams are currently preparing. There's many use case opportunities there. But our first project was to look at some actual data from a customer that had hundreds of remediation projects inside of ENFOS over greater than a 10-year time span. And every quarter of every year, new forecasts are being made on this portfolio, site by site. So we spent time working with the computer scientists at MIT and in our own engineering teams. We did this project, and lo and behold, very early on results were showing that our machine learning outputs of forecasts were actually 62% more accurate than the costs that were being made by the professional teams. That included the customer's project managers, that included the consultants assigned to the projects working on with them. So 62%, that showed very promising results. We were using site attributes, location, that included location, what state, right? What facility type, what group of contaminants of concern. There were technical data within that study as well. And then we also had years and years of forecasting data. And then we also had the actual cost data as well. So we had the actuals to compare against forecasted. What you're looking at here on this chart was just one of the outputs of the whole population. So the curve, the density refers to the population of the sample being tested. So the integral underneath each curve is 1, or you could think of it as 100%, right? So the density on the y-axis has to do with the population of the sample. The symmetric mean absolute value percentage error is shown on the x-axis. It's between 0% and 200%. So you can see that the blue line was the machine learning model output compared to the actual. That's where we were about 62% higher. And the closer you are to the 0 on that x-axis, the more accurate the estimates were for the portfolio being studied. The red line that's the population of the original estimates versus the actuals. So we were very impressed with those early stage results, and we'll certainly continue on this path in looking at how machine learning can benefit our industry. The second project that we've been working on, and this is still ongoing, has to do with data extraction from unstructured content. And what we're talking about here primarily are documents that make up the historical record on the portfolio of sites. So we're talking about site characterization reports, risk assessment reports. We're talking about feasibility studies. We're talking about corrective action plans or remedial action plans. These are pure documents, the majority of which are PDF, but many of them have attachments like laboratory reports, tabular data sets, maps, and so on. So that is a highly unstructured data source. Machine learning in its data extraction algorithms is going beyond what OCR and indexing does. It's looking at deeper levels of classification, understanding, interpretation, and the text analytics. So it's basically, you think about this as data extraction, and it's a text to data, and the machines are being taught to learn what to look for, what is important and what's not, what's redundant and what's not. This will provide a platform for natural language queries, predictions, risk events, and recommendations. Another use case has to do with project matching. So project matching would be we have a new project, or we need a third-party review on a project, something that says we need some information about this project. Project matching is looking, the machine is looking at matching up attributes from that project based on an assortment of different data classifications or data types. Okay, the type of project, the size or magnitude of the project, the location, the complexity, the timing, the remedial objectives, the content from the risk assessment or the conceptual site model, and so on. It also has to do with subject matter expert and consultant selection, because we talked about the human association with projects. Machine learning is going to find organizations and subject matter experts that have been involved in that projects that match up to the one that you're assessing. Obviously, remedy selection and financial modeling as well. So that's an area that ENFOS is continuing to explore around converting highly unstructured data to actual data. I want to show an example from some of the early work we have on this. So this would be an intermediate output, not the final output, but certainly an intermediate output. And the machine learning model here is it's been trained to look for certain types of information within the document repository for a given project. Groundwater flow, as an example, volatile constituents, soil, potential migration routes, reasonably potential exposure pathways, residents, and so on. This is just a snippet out of a very long list of data extraction elements that we're training the model to pull out. So the concept, so we can think about this in several different ways. And I'll use examples. So let's take a laboratory report. We all know that if you're doing data management, you might be using electronic data deliverables, but you've always been getting a laboratory report from the lab that has detailed information in it. So one of the areas that we're going to explore is, can the machine produce tabular data? Can it produce EDDs from the lab report itself? Right, so that's an example. And then can it make interpretations? Okay, and the concept would be to eliminate the electronic data deliverable. So that's an example. These are all areas of exploration, right? Other examples are to create content like a conceptual site model, like a risk assessment, without people entering data. Consultants can do their work, they can create their reports, and just by the nature of machine learning with this unstructured data, the algorithms can produce the key data from those documents and then use that for deeper learning for things like project matching, remedy option selection, and so on. So this is a really exciting area, text to data, and you'll see more on this. This is being done in a lot of different industries, right? Healthcare, manufacturing, and so on. So it certainly can be done in our industry as well. So with that, we are going to move it over into a question and answer section. And we've got some questions that are coming in, so we'll start with those. Okay, one of the questions submitted is, how soon will AI be making a significant impact to our industry, and what has to happen? That is a great question, and I'm not sure anyone has an answer. I think you're going to get opinions on that. A lot of the literature out there right now says that by 2020, machine learning and AI will be a predominant component of all information management strategies. So that's soon, right? And I think that you're already seeing projects taking shape in a lot of different industries. We're seeing AI already in our day-to-day lives and in voice recognition and photo recognition and so on. And the second part of the question was, what has to happen? Well, certainly development of the technologies like we're sharing with you today is important, and different organizations will take different leads on that. But as a commercial software developer, it's our duty to stay on point with the technologies that can help our customers and their consultants. I also think that having structured data is very critical, right? Now, even though we're talking about the unstructured data project, having structured data in advance of these initiatives, having structured data that you can use for analytics with an embedded BI tool, as an example, that's all very important. That also gives you the head start on the use cases. How can this data help us? What questions should we be asking? What should we be looking for that we're not? So that information is very critical. Okay. We have another question. This one was more around, I think, the Internet of Things, which wasn't one of our major topics, but it asked a question about field data collection and sample logging using mobile devices. Where do we see that? I was at a conference not that long ago, and there were a lot of presentations on mobile field data collection. Some very good technologies. There's some commercial applications there. ENFOS has a mobile app. And there's also some custom things that have been built on different platforms. So, but the question gets asked about, where is that today? I asked one of the presenters that information, and I asked them, I said, how much of the field data that's being collected today on environmental projects is being collected on mobile devices or remote sensors? And that person, who I believe was an expert, said less than 10%. Right? So then you have to ask the question, why? Is it because the technology is not there? Is it because of people and change? People aren't willing to change? Are there barriers that just haven't been resolved yet? And probably all those things are true. But I do think that will continue to increase. Will it ever get to 100%? Probably not. But a big part of data collection and data capture will go into this area. So one of the questions we had was, what is OCR on slide 36? So that was a very specific question. What we were talking about there are some standard technologies that have been in use for a while. So OCR stands for Optical Character Recognition, and it is it's basically computer programming that can read files like PDF, certain PDFs, Word documents, and so on, and it's actually attempting to convert. It's reading the words and then creating an actual text of that word on the back end of your system. So it's basically recognizing characters out of documents, and then that's searchable based on different standard these standard searching methodologies like keywords, key phrases, metadata, and then OCR is more used around the content searches. We've got a couple more questions. Okay, one is a very specific question to ENFOS, and it says, can the ENFOS system do 3D data visualization for groundwater plumes? The answer to that is no. That's not ENFOS's purpose. We know those are important in the industry, like a lot of the other enablers that we talked about, but no, that's not what an enterprise software system is designed to do. That'd be more specific to desktop software and your typical GIS type information that you're working on. So that's not an area within ENFOS. We got some more questions. Okay, I mentioned that data analysts spend about 80% of their time preparing data and 20% analyzing it. In what specific ways do you propose to reduce the time necessary for data preparation? It's a great question. So the slide that I showed earlier, let me see if I can back up to it. Okay, here's an example. So and I'm going to speak to this from the ENFOS perspective. So ENFOS is an enterprise system, I think, as most of you know, and ENFOS is capturing structured data through a lot of different modules and a lot of different business processes. Your site information, your project information, your environmental data, your financial information, such as reserve estimates or life cycle estimates, purchase orders, invoices, and so on. So that information is your structured data that exists in a relational database. That information, though, if not normalized, if not clean, is not useful for an analytics professional to go in and start doing assessment. So the data preparation is a step in the analytics process by which someone's basically designing the data schema. They're looking at the universe of data that they want to make available for their analytics package, and they're then doing processes to clean and structure that data so that now it's ready for an end user to be able to start analyzing and using drag and drop for column selection or row selection, using pivot tables and crosstabs, going directly from a tabular data set to a chart. So the data preparation without an enterprise system means that you basically need an army of consultants or an army of analysts sitting around trying to figure out what data do we need, how do we normalize it from site A to B to C to D so that it's useful in a analytics environment. So people are manipulating data in spreadsheets. They're extracting data from multiple sources. They're trying to create valid values. They're trying to eliminate redundancies and so on. So that's a very expensive, time-consuming step in the analytics. So an enterprise system is doing that for you as data is being captured, as it's being entered, and as it's being used. So that's what we mean by that. That step of data preparation is reduced down to essentially zero because the software application is doing that for you. We've got a couple more minutes and we've got a couple more questions. So I'm going to keep going while we've got time. One of the questions had to do with, also it was around the analytics, and it was on the data silo screen that we had, where we talked about all these different data silos. And the question was around, could you talk about the value of having this information in the same place? Well, that's definitely a key element to the ENFOS philosophy, which has always been your data in context is much more valuable to you than your data without context. So we're talking about combining these types of data categories right into the single platform so that I can run queries and I can look for trends, I can look for anomalies, I can look for risk events or triggers that aren't apparent to me when this data is being managed separately and not joined. So that has to do with combining financial data with technical data, technical data with compliance data, as an example. So that consideration has always been part of the ENFOS platform philosophy, but certainly in this area of these emerging technologies, that's even more important, right? Because the tools available to us, whether it's BI or AI, needs to draw upon our data sources, but it needs good data, right? Particularly in the area that we're talking about around structured information. Okay, that seems to be the last of the questions. So Chris, I'm going to hand this back over to you.
Perfect, thanks, Roger. So that wraps up the webinar. Thank you guys for attending. So we're always putting out remediation content. You can find it on our LinkedIn page, on our blog at enfos.com. But if you have any specific questions about today's webinar, or you just want to know more about ENFOS in general, you can contact Michael Douglas at michael@enfos.com or reach him on the number that you can see displayed on the screen. So one last thing, next year in September, we're going to be hosting the ENFOS Experience 2019. So this is where we bring together remediation executives, professionals, and experts for 2 days of sharing insights, strategies, and best practices. So last year, we featured an all-star lineup of speakers. We had the Defense Logistics Agency, we had ChemWars, Ashland, CN Rail, Georgia Pacific, tons more. And 2019 looks to be even better. So this is the first that we're putting out about this. You guys are the first to hear about it. And we'll be putting out a lot more soon. So thanks and have a fantastic afternoon.
Thanks, everyone.